Welcome to this explainer. Today, we're diving into a genuinely fascinating architectural white paper and repository all about Virtual Me, or VME for short. We're going to explore how developers can seamlessly bake AI directly into their daily coding habits. But listen, we are not just talking about another chat window on your screen here. We're talking about totally transforming your entire workspace into an active, breathing digital twin.
We've got a lot of highly technical ground to cover on the agenda today, charting the evolution from a strictly local architecture to a cloud-native, multi-agent future. All right, let's jump right into Section 1, the context window problem and the cognitive load of massive contexts.
Let's start by attacking a completely universal pain point for AI developers today, keeping your AI actually in the loop across a massive codebase. Seriously, how do you manage a 1 million token workflow? Modern problem-solving demands that we juggle system architecture, bug history, thousands of lines of code snippets, and custom-acquired skills, all at the exact same time alongside our large language models. If you've ever found yourself manually copy-pasting a dozen different files into an AI prompt just to get a single annoying bug fixed, well, you know exactly what this struggle feels like.
Dealing with a 1 million token limit is just a massive cognitive load. Traditional tools, like simple issue trackers or static note-taking apps, they really struggle to sync this much context between human developers and AI. What happens? You end up losing track of what the AI actually knows, what it forgot, and the true current state of your workspace.
That takes us to Section 2. Let's meet Virtual Me, your AI native workspace.
This brings us to a brilliantly engineered solution called Virtual Me, or just VME. It represents a total paradigm shift. Think about it, we're moving away from a static workspace. You know, your traditional issue trackers, standard wikis, flat note-taking apps. Instead, we're moving toward an active digital twin. Virtual Me doesn't just statically hold your text, it actively plans, executes tasks, and self-improves right alongside you as a collaborative partner in your development cycle.
To make this possible, VME brings together some really powerful core features. It combines sequential issue tracking with a dedicated skill manager for saving your reusable prompts and system instructions. On top of that, it has a beautifully distraction-free UI, GitHub synchronization, and this is absolutely crucial, token estimation tracking. By managing skills and tracking tokens, it builds your context sequentially. It feeds the AI exactly what it needs without letting you accidentally smash into that massive 1 million token ceiling.
Moving on to Section 3, the local offline architecture, which is 100% local and privacy first.
So before looking ahead to the multi-agent future, we have to look at VM's current foundation. It was built explicitly for strict offline privacy and enterprise constraints, where cloud access might literally be blocked. Right now, it operates as a lightweight, lightning-fast, single-page application. It uses a modern React frontend and an Express Node.js backend to route data to a local SQLite database. The massive takeaway here? It runs entirely offline on your local machine, meaning zero reliance on external cloud databases. It is inherently 100% private.
And even without a complex remote database, version control is handled beautifully. The entire application state is stored locally, sure, but you can back it up as a single JSON blob directly to a private GitHub repository using a personal access token. It syncs your local state securely, giving you an awesome offline-friendly fallback during development while still preserving your context across different devices.
But to support truly advanced autonomous AI capabilities, the architecture detailed in the white paper is undergoing a massive migration from this local stack to a robust cloud-native environment. The database is shifting from SQLite over to Firebase Firestore. Job execution is moving from a simulated local interval loop to Google GenKit running on Cloud Run, and the AI integration, that's leveling up to utilize the highly capable Gemini 3.5 Pro and Flash APIs.
That migration sets the stage for Section 4, the multi-agent orchestration workflow, passing the baton. This cloud migration leads us right to the absolute climax of the entire system, the orchestration engine. This is really where the magic happens. Instead of you just firing off a single massive prompt and crossing your fingers, VME's queues a job that passes the baton between specialized digital teammates. Step 1 is the planner agent, who breaks the task into deterministic steps and anticipates dependencies. Step 2 is the executor agent, the real doer, who writes the actual code. And Step 3 is the QA agent, an adversarial persona that evaluates the output and literally demands revisions if your rules aren't met. It is exactly like managing a mini engineering team right inside your laptop.
So how does this workflow actually flow? Well, this orchestration sequence happens completely seamlessly on the back end. When you submit a task via the UI, The Express server utilizes Google Genkit and the Gemini API to pass structured data between these distinct personas. It summons the planner, hands off the plan to the executor, and eventually saves the final, verified result securely back to your database.
Which brings us to Section 5, RAG and the Memory Bank, connecting real-time intelligence.
To make this multi-agent orchestration actually feel real-time to the user, and to ensure the AI maintains a flawless memory across sessions, the architecture leans on two highly critical concepts. First up are server-sent events, or SSE. Unlike traditional REST APIs that just time out after 30 seconds, SSE keeps the HTTP connection wide open during the AI's deep thinking phases. It pushes real-time AI token streams directly to your front end. This means that even while the planner agent is thinking through a massive architecture change, the response stream feels like a live typing experience without any of that frustrating buffering.
The second concept is RAG, or Retrieval Augmented Generation. In the new architecture, the system connects to Firebase Firestore, which essentially acts as a NoSQL memory bank. RAG allows the system to pull in historical, cross-session context so your digital twin never, ever forgets past lessons.
When you submit a task, VME fetches your active workspace issues and generates query embeddings using Google's text embedding models. It then performs a cosine similarity match, which is basically finding the mathematically perfect match in your vector store of saved skills. By doing this, the system dynamically injects your highly specific coding guidelines into the agent's prompt right when it needs them, without permanently bloating your 1 million token limit. It is an incredibly efficient assembly flow.
And finally, Section 6, the Future Developer Workspace, evolving beyond the wiki.
Let's look at where this project is heading for the future of solo software development. With upcoming roadmap features, this architecture pushes way past simple to-do lists. We are looking at Ollama integration for a local LLM fallback in case you lose internet. We're looking at agentic memory compaction to automatically compress historical issues in the background. But perhaps most excitingly, expanded tool integrations will give the executor agent direct file system access within a Docker sandbox. So the agent won't just write code, it will be able to safely test it in an isolated environment before ever handing it back to you.
As the white paper perfectly states, this setup changes absolutely everything. Quote, "The workspace transforms from a static repository of files into a collaborative partner." What you should really take away from this explainer is that your tools shouldn't just be passive storage anymore. They should be active, participating members of your engineering workflow.
So I want to leave you with this final provocative thought. As coding workflows inevitably hit 1 million tokens and beyond, and the sheer cognitive load becomes way too much for traditional tools, are you ready to bring a robotic coworker into your loop? Thank you for tuning into this explainer, and I highly encourage you to go dive into the Virtual Me repository to see this wild architecture in action for yourself.